Hello, Calculus AB students. Hope you're doing well and that you've had a good Thanksgiving break. As I mentioned in my email, I just want to give you a chance to do a little reviewing and just a brief look ahead as to what we'll be working on this next week when we come back to school. So when we left before Thanksgiving break, the last thing that we worked on, the last kind of day and a half or so, was the average value of a function. And so I'm hoping that when you look at number one, the language looks pretty familiar. And you might be able to do it. So feel free to pause the video and try it on your own. But I'm going to go ahead and work this one here for you. So notice here that the instructions are really pretty straightforward. It says find the average value of g of x equals cosine of x on the interval from 0 to pi over 4. And so this, like I said, this is really clear instruction. What we'd want to be able to do here is know or be able to recall the formula to determine the average value of a function. So here it is. This is the most generic version of it. 1 over b minus a times the integral from a to b of g of x dx. This would give us the average value of g of x on the interval from a to b. So let's identify our a and our b here first. Those are just going to be the endpoints of your interval. So I think our a and our b would be 0 and pi over 4. So I'm going to start off by saying the average value of g of x is equal to 1 over pi over 4 minus 0. Of course, the order certainly matters where the a and the b are. And then it'll be the integral from 0 to pi over 4 of g of x. And of course, g of x is cosine of x. So then to evaluate this, we need to use the fundamental theorem of calculus part 1. So I'm just going to have this 1 over pi over 4 hanging out here. To be able to evaluate the definite integral, I need to find my antiderivative first. The antiderivative of cosine is sine. And this is going to be evaluated from 0 to pi over 4. So using the fundamental theorem of calculus part 1, I'm going to go ahead and copy dot flop this if you don't mind. It'll be 4 over pi. But then it'll be sine of pi over 4 minus sine of 0. A little bit of evaluation of some trig and we'll be done. So it'll be 4 over pi times root 2 over 2 minus 0. And that, of course, when I multiply, be 4 root 2 over 2 pi, which is the same thing as 2 root 2 over pi when I reduce my fraction. So that would be the average value of that function cosine of x in the interval from 0 to pi over 4. I want to make sure that we understand exactly what we're doing here, so I think that it's maybe a little bit easier to see this on a graph. So here is the x and the y-axis. And so if we look at a graph of cosine of x on this interval from 0 to pi over 4, cosine would look maybe something like that. So 0 here, pi over 4, pi over 4, there we go, there. So essentially what we're doing is we're saying with all the y values on this interval, so all of the y values along this stretch of graph, we want to find the average of all of those. And so what we end up doing here, of course, is we do the integral to add all of them up. Remember that a definite integral is simply an infinite summation. And then we divide by the full width of the interval to figure out where that average value is. And of course, the average value is going to be somewhere within the range. Maybe it's going to be like right in there or something like that, or maybe a little bit higher, maybe up here, probably too high. It's going to be somewhere there in the middle, where we actually have this average value, the average y value for this particular function. Okay, so you'll get a chance to work again with this a little bit when we come to class during our first meeting. I want to do one brief look ahead, so let's check out this next one. So we have done a lot with definite integrals so far. Even early on here in chapter 4, we've already done quite a bit. So from a graphical standpoint, what we've done is we've said, if we've got some function, and let's say that function, I don't know, looks something like this. We have had a domain from A to B, and we've said the integral from A to B, we're going to call this f of x dx. So that graph is a graph of f of x. We're going to be doing the definite integral from A to B. And of course, if you guys remember, we're able to use area to help us with this. So calculating this definite integral would give us this area right here. And we could be a little bit more specific numerically, like often instead of an A and a B, we have like a 0 and 5, something like that. And that, of course, would be reflected in our definite integral. So instead of an A and a B, this would be a 0 and a 5, just to be a little bit less generic. So, we've learned how to do FTC1 to actually evaluate that. And so we've done a lot of that already. So these accumulation functions are going to be based on an integral, based on a definite integral to help us define a function. So I'll show you what that might look like. So we might have some function that's defined like this. G of x equals the integral from 4 to x of, I'll use h of t dt. So what is this all about? Well, all this is really saying is that g of x, some function, is defined as an integral from 4 to some variable. In this case, I've written an x up here, of some function h of t. So here's what that might look like in a graph. Maybe I would have a graph of h of t and maybe h of t does something like that. Well, g of x would simply be the accumulation of y values from 4 out here to some unknown x. Where is that x located? It could be located anywhere, really. And depending on what it is, we'd be accumulating y values in different ways. So, for instance, if I needed to find g of 7, that means that x is 7. So it'd be the integral from 4 to 7 of h of t dt. So in this case, I would just accumulate from 4 out here to 7, and whatever that area happened to be, that would be what g of 7 actually is. And this actually illustrates the point of why, and you might have wondered about this, why is this a t, why is that a t when this is an x up here? Point simply is this: if you're looking for g of 7, then if you plug a 7 in for x, you have to plug a 7 in wherever you see an x. And so in these cases, we would not want a 7 to go in right there, or right there for that matter. We want that to remain a variable, and so we use what's called a dummy variable. The t is just stands for some other input, just to not confuse the situation with what is the actual input for this function. The input is x, so we're going to use a different letter for the variable of integration. So I just wanted to get this look kind of in your mind. I'll write this again over here. I'll just say, g of x equals the integral from 4 to x of h of t dt. This would be what we might call an accumulation function, and this accumulation function could be we could do a number of things with it for sure. When you come to our first meeting this week, one of the things we'll look at is how do we do a derivative of it, and what does that look like, and we'll kind of complete and round out the fundamental theorem of calculus. Okay, so I think that is probably good enough. I'll look forward to seeing you during our first class. Hope you've had a great break. See you soon.